Hello, welcome back. Did you hear what happened to the Hokey Pokey addict? He really turned it around. Okay, we've got another video on simplifying surds today. I'm going to call it part 2 because we already talked a little bit about simplifying surds in the previous video, talking about simplifying surds that look like this. But the next step is to kind of, I guess, look what happens when we multiply different surds together, and especially what happens when we do binomial expansion. So I want you to think, as we're dealing with these surds, it's very, very similar to algebra, and we treat the surds kind of like terms or like surds. And very similar to algebra, you think numbers with numbers, surds with surds, especially when you're multiplying. And I'll show you exactly what that looks like. So just remember, if I have root A times root B, what does that really mean? Well, I can just rewrite it as root AB in one surd together. So if I've got a question like this, I'm going to use blue. Root 3 times root 15, I just multiply the two together. So root 3 times root 15, that becomes root 45. And then from here, I can recognize that that can be simplified with a square number. So it's going to be root 9, root 5. And that's just going to be 3 root 5. And that there should be my final answer. Okay, now incorporating some index laws here, I've got 2 root 5 squared. And I know some of you guys will miss this, so I'm just going to write it out. So that we're going to write it as 2 root 5 times 2 root 5, because that's what squared means. And then now we'll just go numbers with numbers, so as we said. So now I've got 2 times 2, which is 4. And then root 5 times root 5, which is going to be 5. So in this case here, my answer will be 20. Okay. And again, taking a look at these ones here, I've got numbers with numbers, surds with surds. So 2 times 5 is 10. 4 times 3 is, well, root 4 times root 3 is root 12. And I can break that down a little bit further. I can break it down as 10 root 4 root 3, because there's a nice square number there. So it's going to equal to 10 times root 4 is 2. So this is going to be 20 root 3. And that'll be my answer there. Right, the reason I multiply is because they're all next to each other. Okay, now if I have something like this, root 32 on 2 root 5 times root 10, my goal here is to simplify everything as much as possible. So I can see the top will be root 16 root 2, because that's a nice square number there. And on the bottom, I'm just going to simplify this first. 2 root 5 times root 10, numbers with numbers, so I guess it's just 2. But then root 5 times root 10, which will be root 50. Okay, so simplifying this even further, I can see now that root 16 is 4. So I've got 4 root 2. And on the bottom here, I can see this will be 2 root 25 root 2. Okay, so here I've got 4 root 2 over, and here I've got 2 times root 25, which is 2 times 5, which is 10. And very similar to algebra, if I've got 1 on top, I can cancel that with 1 on the bottom. That leaves me with 4 on 10, but I can simplify that to 2 on 5. And I believe there's a little bit more. So there's a truck. Just remember that if I expand these out, this gives me AC plus AD plus BC plus BD. If I have A plus B squared, that's a nice one. That's A squared plus 2AB plus B squared. A minus B squared is the same thing, just minus the 2AB. And then the last one, A plus B, A minus B, becomes a difference of 2 squares. That's A squared minus B squared. So these ones here are just going to help us out. Now, if I take a look at these expansions, we just expand as usual. So root 3 times 2 root 5 is going to be 2 root 15, take away root 3. And in this case here, I'm happy to leave my answer there because I can't really simplify that any further. It just is what it is. It is what it is. Now this one here, root 7 times 4 is 4 root 7. Root 7 times root 7 is 7. Minus 3 times 4 is minus 12. And minus 3 times root 7 is minus 3 roots 7. So collecting like terms here, I've got 4 root 7 and 3 root 7. Minus 3 root 7, so that just becomes root 7. And then I've got plus 7 minus 12, that would be minus 5. There's my simplified answer there. This one here, if I'm taking a look at it, I can recognize that this is a difference of 2 squares. So I know it's just going to be the first term squared, take away the second term squared. So root 3 times root 3, I'll do the long way. Root 3 times root 3 is 3. Root 3 times 2, so I just did that one. The next one is this is going to be plus 2 root 3. This one here will be minus 2 root 3. And that one there will be minus 4. So your 2 middle terms cancel out. Because you got plus 2 root 3 minus 2 root 3, so that cancels. And I've got 3 minus 4, which gives me an answer of -1. And last one, we've got here a perfect square. And so I know it's supposed to be a squared minus 2ab plus b squared. But again, if you're uncomfortable with that, feel free to expand it the long way. I'll show it here because I've done the expansion the long way for one of these, so you can figure it out yourself. Go watch the other videos. So here I know it's just going to be a squared, which is going to be 16, minus 2 lots of a times b. So minus 2 lots of 4 times 2 root 2. So 2 root 2 times 4 times 2. Yeah, I'll do it in order, 2ab. So it's going to be 2 times 4 times 2 root 2 plus b squared, which is going to be 2 root 2 squared. And to clean that up, I'll get 16. Minus 2 times 4 is 8. Times another 2 is 16. And then that becomes 2 root 2 squared becomes 4 times 2, which is going to be plus 8. And that there should be our answer. Okay, if you want to write it as 4 minus 2 root 2 times 4 minus 2 root 2, and then expand the whole thing out. But if not, that is it. Have a great day and have fun. Bye-bye.